Hello everyone, welcome to this online course on manufacturing processes. I am Hari Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So far in this manufacturing processes course, we have completed casting and we are doing welding. So in welding, two lectures is already completed. In that, we saw how to classify the manufacturing processes broadly, and starting in first lecture. In the second lecture, we saw the basics of the welding, what is the welding, and then we also saw how to classify the welding processes. Okay, so today we will start the all the processes. Like we saw what arc welding is there, then solid state all welding processes are there. So today we'll briefly see one by one what is the meaning of arc welding, what is the meaning of resistance welding, what is the meaning of gas welding, then solid state welding, and of course we'll see the weld morphology. So one by one today lecture we are going to discuss about these things. This is what is arc welding in general, and then we'll see what is resistance welding, then we'll see of course the gas welding, then solid state welding, and then weld morphology. In the last lecture we have already discussed what is the meaning of arc welding. No, sorry, we discussed how to classify the welding processes, and we saw broadly it is being classified in fusion or liquid state welding and solid state welding, depending upon what is the state of the material during the welding. Means if solid state is changing to liquid state, then we saw it will be fusion welding or liquid state welding. And if the state is not changing during the welding, so we saw friction stir welding is there, friction welding is there, so these processes are there. During welding the state will not change, so that we saw it will come. So today briefly we'll see all these processes. So let's start this lecture. So first we are seeing arc welding. So arc welding means the heat source is the arc. So now the first thing is how arc is generated. So stepwise we'll see here. First, these two parts are there that we have to weld. This is the first part and this is the second part. Okay. So through arc welding we have to join this one. Now most of the cases in arc welding, these two pieces that has been taken here is of generally of same nature. Same nature means if this is the mild steel, this also will be mild steel. If this is the other material, some other metal, suppose these two are the aluminum pieces, so this will be aluminum piece. Suppose this is A1, so this will be A2. If it is mild steel, so this also will be mild steel. Okay, most of the cases, but it's not generalized. Means we can use different materials also. So different materials can also be welded. So these two materials we can see here, we are going to join through this butt joining. Means edge to edge we are going to join these two materials. So we'll see what is the meaning of arc welding. In this operation, electric arc is generated. What happens if you'll see the diagram, through diagram? Suppose this is the power source, and this power source is connected to an electrode holder. This is the electrode holder. Okay, and here electrode is holded, and suppose this is the workpiece. This is the workpiece. Okay, and this is the electrode holder. So this workpiece is going up to this one. So we can draw like this. So this is here, and this is suppose the electrode holder. We are holding the electrode, then arc will be generated in this area. So what how this is being generated? Once this will be in contact, slightly will lift this one. Okay, now so in this arc will be generated, and the this part which is the arc, this is known as arc length. So this arc will be generated, and because of that, what will happen? Heat will be generated over there, which we need to weld the two parts. So this is the two parts. For example, this part we have taken, and this part we have taken. We have to weld. So because of this arc, heat will be generated in this area. Beside this, many things are being added over there. For example, if I am doing welding in a particular lab where there is no shielding, shielding means it is open to the atmosphere. If it will be open to the atmosphere, we know there is oxygen over there. So if there is no shielding, means we have not covered those area from this atmosphere, then what will happen? That oxygen will react with that one, and what will happen? It will form the oxide over there, and oxides are generally very brittle materials. So what will happen? These brittle materials will bring brittleness in the welded part. So it will not be good for the strength and not will be good for the specimen also or the part that we are going to weld. So what we generally do with this one, once arc will be generated, we generally use shielding gases or whatever the electrode we are using as a filler. This electrode, suppose we are using as a filler, so these electrode will be coated with the different kind of materials, generally known as flux. So what will happen? This electrode will be coated. So what will happen once this electrode will be melted over there? So this coated flux will come and it will cover the entire area. So wherever we are doing the welding, the whole section will be completely covered so that it will not be exposed to the atmosphere. And atmospheric air, especially oxygen, will not be in contact with this one. So there will be no oxide formation during the welding. So not only this one, so arc is generated in this area in arc welding. First arc will be generated and then shielding gases or coated electrode will be used. Okay. So it will shield this area. Okay, and then of course this molten pool wherever the material will be melted, generally in fusion zone. So this melted electrode means it will be deposited over there, and then this base metal also will be melted over there. So the whole area where it happens is known as molten pool. Okay, and finally our welding will be look like this. Once it will be completed, it will look like this cup shape. Okay, so this is the welding. So in arc welding, how heat is generated through the arc, heat will be generated, and with this that arc for the shielding processes, in most of the cases inert gases are being used. These inert gases may be helium, it may be neon depending upon the application, or active gases also may be over there like CO2 for the shielding processes. Shielding processes we are not using at inert gases, so generally coated electrodes are used. So what happened during the welding, that coated electrodes wherever the coatings are, that this the flux, it will completely shield the area wherever we are doing the welding, and it will hinder it to interact with the environment. So this is all the stepwise, these are the three steps we have shown here for the arc welding. Next is resistance welding. Resistance welding, actually here the Joule's law is used. What is the Joule's law? H is equal to I square RT. Okay. So I is the current passing through the circuit, R is the resistance, and T is the time for which the current is flowing. So based on this fundamental, resistance welding actually is based on. So what happens here in this operation? Electric resistance is generated to the flow of the current, generates the energy between the contacting surfaces. You can see here these are the electrodes actually, and externally it will be connected to the power source. Okay, so these are the electrodes. Generally it is made up of copper. So if these two are made up of copper, this one and this is the part that we are going to weld, it is in lap configuration, one over the another. So all this electrode, this materials and this contact, wherever the contacts are, combinedly all this will participate in creating the resistance. So what will happen if it is connected through the power source? So what will happen? Current will flow through this one, and because of all this there will be hindrance in the current flow. And if there will be hindrance in the current flow, we know through the Joule's law, this will produce the heat over there. And what will be the value of the heat? The heat produced over there will be a square of the current which is flowing through the circuit into what is the resistance into for what time this current is flowing through the circuit. So these three parameters will actually contribute for the generation of the heat. So heat will be produced over there, and this heat will be used to weld the specimen or the piece over there. We can see this is the biggest drawback of this process. Why this is biggest drawback? Big, only we can do welding in lap configuration. If we have to join two parts in what configuration, that is not possible in this process. So in detail we'll see once we'll come to this process. Next is gas welding. So as I told at the starting, during the welding, if we are using heat to join the parts, two or more parts together, different sources may be used to produce the heat. So here what we are saying, resistance, contact resistance is the main source through which heat is being produced. But here this is not the case. Here exothermic reaction will be the main source to produce the heat. So what will happen? Acetylene actually will react with the oxygen. Acetylene means C2H2, and because of its reaction with the oxygen, heat will be produced. Heat will be produced. Of course, CO2 will be there, and heat will be produced. So this heat will be used for welding processes. Okay, now and we'll see later this reaction actually happens at two zones. One is known as inner zone and one is the outer zone, and temperature of these two zones will be different, and also different kind of flames will be there. Okay, now it may be oxidizing flame, it may be reducing flame, it may be neutral flame, depending upon what volume of acetylene and what volume of oxygen we are mixing together and then igniting over there. So depending upon their volume or their quantity, different flames will be generated. So what is the main thing here? The main thing here is what is the source of the heat that we are going to use. The source of the heat is actually the exothermic reaction between whatever the fuel that we are using over there. Most of the cases acetylene is used. That's why it is also known as oxyacetylene welding process. So this C2H2 will be there. It will react with the oxygen. Okay, that has been written here. There, the oxy fuel gas welding is a welding operation in which heat is generated by a hot flame generated. Okay, na generated mixture gas of oxygen and acetylene. This C2H2 and O2. Actually, these two mixer will be in just like a carburetor, that a welding torch will be there, and it will be mixed over there, and then it will come out and will ignite, and then heat will be generated. So all this we will see in detail once we will come to this process. The next process is solid state process. So in solid state process, already we have seen that there will be no melting of the material. Whatever the material we are going to weld, suppose this is the one piece I am welding and this is the another piece I am welding, okay, not together. So what will happen, suppose this is mild steel piece 1 and this is mild steel piece 2. So what will happen if we are doing welding at this section, so material will not be melted over there. Although the temperature will be very high, more than the recrystallization temperature of the material, but it will not reach to the melting temperature. If it will not reach to the melting temperature, what will happen? There will be no state change over there. That is the definition of the solid state welding process. So here in this method, joining is done by coalescence of resulting from the application of pressure only or combination of pressure or heat. Okay, now both can be there. Like suppose we have to weld these two pipes. Okay, now suppose these two pipes are there. One is fixed in friction welding. We'll see. So one is fixed here, and another one which is free to rotate on its axis. And suppose it is free to rotate in axis with this omega speed. So what will happen as these two are in contact at this point? So because of the relative motion, there will be friction between these two parts, and because of this friction, heat will be generated in this area. Once that heat will be sufficient, so that this the part which is in contact will be sufficiently plasticized over there, then what will happen from both sides, from this side and this side, will apply the pressure, and once we'll apply the pressure, here the part will be joined together. So that has been written here. We can use heat, we can use pressure, both can be used, but it's not necessary. Only heat also will be sufficient, only pressure also will be sufficient to join the two parts together. That has been written here. Even if heat is used, the temperature in the process is less than the melting point of the metal being welded, unlike fusion welding. As we have seen in fusion welding, what will happen? The temperature that or the heat that we are providing for welding, it will melt the material wherever the part or the section that we are going to weld together. So it will be melted over there, just like in fusion welding. But here, what will happen? Although we are providing the heat over there through the different sources, but heat will not be sufficient to melt the material. Okay, it will always be in solid state. Okay, another advantage of this process is there will be no filler used in this process. We have already seen in resistance welding also, although it is a fusion welding, there will be no filler. Here, in almost all the solid state processes, where we are using friction welding, we are using friction stir welding, or we are using explosive welding, or we are using roll bonding. Whatever the process is, there will be no filler used over there. Many examples are there. Diffusion bonding is there. No, there will be heat and there will be pressure over there. There will be atomic diffusion, and then there will be welding between the two parts. Then friction welding or friction stir welding is there. Then we have example of ultrasonic, because of the vibration the parts are going to join together. Explosive welding is all the processes. It all comes under the category of, we have not written here. Yeah, explosive welding is there. Roll welding bonding is also there. Roll bonding. This also comes under the category of solid state welding. Here also material are not melted. during the welding. So all these processes comes under solid state process. So what is the basic fundamental? The fundamental thing is here heat will be produced whatever the methods we are using, either friction or some other source, but that heat will not be sufficient to reach the material temperature up to its melting point. So material will remain in solid state. Although temperature will be very high, but it will not reach to the melting temperature. So that is the basic fundamental of this process. Next, we will see the weld morphology. Weld morphology means suppose we are doing the welding. So what happens? Suppose this is the one piece we have to weld, and this is the another piece we have to weld. Okay, now. So suppose we are doing welding. This is the is wise we are joining together, means what welding we are doing. So the part which will be melted. Melted means this base metal. So some part will be melted because we are applying heat here. And suppose some electrode we are using, that we are filler also using. So this filler is also being melted and being deposited in this area. So what will happen? This whole area will be melted, complete mixed. Okay, now with the base metal as well as if you are using filler. So this part is known as fusion zone. Similarly, adjacent to this part will be there. Again, some part will be there. So these are the different zones which is generated during the welding. Also, accordingly, as the heat is there and materials are there, so their microstructural feature means their microstructure also will be different. Okay, now. So generally, these four zones are classified, or uh, we can say that there are generally these four zones exist during a welding process. What are those four zones? Fusion zone will be there, weld interface will be there, heat affected zone will be there, and unaffected base metal will be there. Okay, now if we are doing solid state welding, especially we are doing FSW, for example, FSW friction stir welding. So one more zone comes over there, because in friction stir welding, we'll see in friction stir welding, plastic deformation is also there. So one more zone is being added over there, that is known as thermally mechanically affected zone. Okay, now thermally mechanically affected zone. Okay, so that will be the extra that will not discuss, because most of the welding processes which are there in our syllabus, most of the welding processes which are there in our syllabus is actually based on these two only. So that is not there in most of the cases. This will be especially arc welding. So once we'll come to, we'll see in syllabus, most of the processes that we have to study according to our syllabus is actually based on arc actually. So arc welding. So in those kind of processes, these four zones will be there. So what is the meaning of this one? If you'll see this one, we have already seen, typically when two plates or two parts are being welded together, it will look like this one. So what will happen? This is the zone which is known as fusion zone. Okay. So as I said, fusion zone means here the material will be mixed. Material will be mixed means your base metal will be there, base metal plus whatever the filler material has been used. This filler material, both will be melted, and in this area it will be mixed together. Okay, no? It will be mixed together. Okay, and here obviously the heat input will be the highest. So this microstructure that is here is actually columnar grains will be there in this fusion zone. So this corresponds to this one. Okay, na? And heat input here will be the highest. Adjacent to this one, there will be a small section. We can see here, just adjacent to this one. This is known as weld interface. This is the interface. So interface means the zone between, a small narrow zone between this fusion and heat affected zone. So this is a small narrow zone. We can see here this zone. This is the narrow zone. This is a very narrow zone. This is known as a weld interface. And what this narrow zone is, it actually differentiate or uh, act like a boundary between the fusion zone and the heat affected zone. This is the zone, heat affected zone. So this complete area is heat affected zone, and between these two, this fusion zone and this heat affected zone, we have a narrow zone which is known as weld interface. What is this heat affected zone? Heat affected zone means this part is affected by the heat. Heat is not equivalent or equal to the fusion zone here, but heat has affected this zone, not up to that point that the material will be melted over there. What is the meaning of this one? It heat affected or material in this zone will not be in liquid state. Not be in liquid state means it will not be melted over there. But whatever the amount of heat is there in this particular zone, it will be sufficient to change the microstructural feature of the material. So this will change. So this correspond actually to this one. Okay. So in this one also two sections will be there. One section just near to this one and one section just out to this one. So this is the coarse grains which is near to this one. So you can see here these grains are coarse, okay, where the heat has affected. Matlab mostly grains has been affected by the heat, and this is the outer part of this heat affected zone. Here the grains are relatively finer over there. So in heat affected zone also two parts are there. One just close to the fusion zone and just away from the fusion zone. So these two parts are having different microstructural feature. Generally, which part is near to this one has coarse grains and just outer, the outer of this one or away from this one, it has a finer grain. So that has been written. The finer grains in the edges away from the weld interface. So that can be seen. And finally, the last zone is on the affected base material. Means here material is not being affected by the heat. So what will happen? Whatever the grain structure was before welding means suppose these two pieces base material are there that we are going to weld together. So whatever the microstructural feature was and whatever the microstructure was, it will remain same. It will not be affected. Generally, materials will be cold work. Suppose it has been rolled or it has been extruded or it has been forged. So whatever the grain structures are at the starting, this is elongated grains, it will remain as it is in the base material. So this is the weld morphology. We'll stop this lecture here. Next we'll see some other process. So thank you.